Hello to all geometry students. In this video, we will be going over the Geometry 2022 June Regents exam, and in this video, we'll be covering the multiple choice questions 1 through 15. So for this geometry examination, you will have 3 hours to complete the test, but you have to stay for 2. A huge, crucial part of geometry is really just reading the questions fully and understanding and not just skimming over. Okay, so problem 1. Triangle A prime, B prime, C prime is the image of triangle ABC after a dilation centered at the origin. The coordinates of the vertices triangle ABC are as listed. I personally like to bring a highlighter into my exams. You can bring a highlighter onto the Regents exams and really just grasp what you're doing. I like to just note that those points are there as we read the question. If the coordinates A prime are -4, 2, the coordinates of B prime are. Now, if this is a dilation listed or centered at the origin rather, if the question is talking about A prime, we are only really focused on A at this moment. So I like to just write -2, 1, and then A prime, sorry, I kind of scribbled it out, -4, 2. Now, since this is just centered at the origin, you really have to find what gets this value to equal this value, and vice versa on the x-coordinate. Now, 1 times 2 would equal 2, and -2 times 2 would equal 4. So once you establish the rule, that is what you will be doing for the next thing. So if B is 2, 4, that would mean B prime would be 2 times the x-coordinate as well as 2 times the y-coordinate. Gives us question 2. Please don't be tricked by question 1. The Regents does this a lot. They just want to make sure you're paying attention and fully reading the questions. Moving on to question 2. In the diagram below, a plane intersects a square pyramid parallel to its base. Which two-dimensional shape describes this cross-section? Now, this question could be very easy or hard depending on the time it took you to really grasp the problem. So a square pyramid, listed below, parallel to its base. So this would mean if this is the base, which it is, you would cut it this way. That means the cross section would end up a square. So the answer is square. The reason students go wrong with this problem is if they read it wrong. So if you completely skipped over the parallel part, some students would think you would cut it this way, resulting in a triangle, but that is not right. So number 2. Question 3. In the diagram below, triangle CDE is the image of triangle CAB after a dilation of DE over AB centered at C. Which statement is always true? So this is a problem of similar right triangles, as you should get from, this is the image after a dilation. So dilations create similar triangles, not congruent triangles. So you are dealing with sine and cosine, and for this problem, it's a trig question. So, ka, toa, we really need to know this. Now, this problem a lot of students would just guess on, but I really emphasize drawing it out. Visual is really important in geometry, and it personally for me, and I find a lot of students, it helps us. Okay, so we're going to draw the big triangle, CABC, this one right here, and we're also going to draw the little one, DEC. So the sine of A would be the opposite side to its angle and the hypotenuse. So opposite of A would be BC and CA. Now you want to translate these to corresponding sides on this triangle. So BC would be CE, and then CA would be CD. So these are equal proportions, and that would be the correct answer. 1. Question 4. A regular pentagon is rotated about its center. What is the minimum number of degrees needed to carry the pentagon onto itself? So this is definitely a more just fact-based. You need to know what a pentagon is. You really need to know your shapes in geometry. So a pentagon is a five-sided figure. This is my pentagon. It's not accurate, but this has 1, 2, 3, 4, 5. 5 sides. So what is the minimum number of degrees needed to carry the pentagon onto itself? Now, this problem, you've probably done it in class before. So it's asking for the minimum. So yes, 360 degrees would be correct, but it's wrong because the minimum is less than that. So what you need to do, you need to figure out how many sides you have and divide that by 360. And that would give you 72 degrees. So answer 1. Question 5. On the set of axes below, triangle ABC is congruent to triangle A prime, B prime, C prime. Triangle ABC maps onto triangle A prime, B prime, C prime after A. So this is a problem of congruency. That means a rigid motion must have been happening, so it preserves angle and distance measure, so no dilations. But if we look at the answer choices, a dilation is not listed as such, so we cannot cross any off at this moment. Reflection over line y equal negative x. This is about that line right here. So if we look at this triangle right now, let's just focus on point A. If we flip this triangle over this line, A would not map to A prime. It would map to B. So that means 1 is off the table. And similar to question 2, it is a bit of a different line. However, it still has this negative slope, and A would still map to B, which is just wrong. These next two questions are focused on rotations. So rotation of 180 centered at 1, 1. So that's about this point right here. So if you just focus on B, you would have to go up 1, 2, 3, 4, 5 units and 1 to the right. So up 5, 1 right. So this would mean for B prime, you would have to go down 5, 1 left. The opposite. So 1, 2, 3, 4, 5, 1. That checks out. That's the answer. Right triangle TMR is a scaling triangle with right angle at M. Which equation is true? So you have to draw this one out. If you don't draw this problem out, there's no way to really figure it out. So right angle at M, TMR. The sine of M, this angle right here, would be TR over TR. The cosine of T, this angle, this angle right here, would be TM over TR. These do not equal each other, therefore question 1 is wrong. For answer choice number 2, the sine of R is TM over TR, and the cosine of R is MRTR. These are not equal, so that is not the correct answer. Sine of T would be MR over TR, and the cosine of R would be MR over TR. That is equal, so number 3 is the correct answer. Question 7. In the diagram below of triangle AED and line ABCD, AE is congruent to line DE. In this problem, we're given this big triangle with lines AE and DE. Now, a very, very crucial thing in geometry is to not assume. So do not assume anything that you might think is common sense. Because in geometry, we're trying to prove that common sense, you say. So do not assume anything. AB congruent to AC. Well, they sure do look like it, but nothing in our givens would provide that congruency. So no. AC is congruent to BD. Now, yes, they do look congruent. However, nothing in our givens provides that information, so that is wrong. Angle EBA is congruent to ECD. Well, they do look congruent, but no information in our givens provides that information. Angle AEC is congruent to angle ABD. Now, This is the correct answer. And you might be like, oh, like, why did you get that answer? Because in a triangle, in one singular triangle, if two sides are congruent, that means their opposite angles are also congruent. Now you might be asking, well, why isn't it answer 3? That's because in answer 3, these two angles are not in the same triangle. So therefore, this theorem doesn't work. So that means the answer is 4. Question 8. In the diagram below, right triangle ABC has side lengths of 8 and 15. The triangle is continuously rotated about AC. The resulting figure would be. Now, you have to read this problem because I've messed up on problems like this. You've messed up on problems like this. Your classmates have messed up on problems like this. It's so crucial to really take your time. You have 3 hours on the Regents. I guarantee you will finish. You won't you won't run out of time, I promise. It's plenty of time. So if it's continuously rotated about AC, this point, that means we're going to end up with a shape kind of looking like this, but it's of course 3D. So that would be a right cone if we're looking at it correctly. So not a right cylinder. So that off the bat, that marks off 2. Now you really have to be careful with these questions because they will try to trip you up and it is kind of hard to see sometimes, especially if you've been sitting there for 2 hours and you just want to get out. But I encourage you to really take your time. A right cone with a radius of 15 and a height of 8, or a right cone with a radius of 8 and a height of 15. So if you are looking at a cone like this, the radius is half. So the radius is 15. That does not change. The full thing would be 15 on the other here because we double this value. So the radius is 15 and the height does not change. The height will always remain the same. So this would be 15, but the height is 8. So choice 1. These problems are kind of tough. Question 9. In the diagram below, lines K and L intersect lines M and N at points A, B, C, and D. Which statement is sufficient to prove ABCD is a parallelogram? Okay. These ones, you really do have to draw on them, mess it up, look at it. Angle 1 and 3 are congruent. Well, these are corresponding angles, so that would prove that line M and N parallel. However, that's not really enough to prove anything about a parallelogram. That answer choice is out. Angle 4 is congruent to angle 7. So these are alternate interior angles, so that means lines K and L would be congruent, but that also doesn't really give us much, not enough to prove anything, so that is not the answer choice. Answer choices 3 and 4 have an and section to them, so this is very important. If angle 2 and 5 and line 5 and 7. So 2 and 5 are alternate interior angles, so that would mean that lines K and L are parallel. And if 5 and 7 are equal, then that would mean that lines M and N were parallel. So this gives us a quad with two sets of parallel lines, and that means it's a parallelogram. So the reason the last answer choice is wrong, 1 and 5, these give us M and N parallel, but 3 and 4 are really just vertical lines, and we would have figured that out anyway, even if they didn't give it to us, so that's why it's not right. Question 10. Which transformation does not always preserve distance? So this means it would have to be a non-rigid motion. Hopefully, you know that this would be a dilation. So a dilation, you would have to multiply a point, xy, to be a non-rigid motion. So in answer choice number 1, we are really just adding, so that would be a translation, so that's a rigid motion. And in 2, we are really just swapping them, so that's rigid motion. But in 3, this 2x, we're multiplying x by 2, and that does not preserve distance. So that is the correct answer. Question 11. In the diagram below, EF is parallel to HG, EF equals 5, HD equals 12, and all these givens. So I really like to, I'm a big fan of marking my diagram like they've already done in this problem, but if they have not, please mark your diagram. It makes it so much easier, so much more visual. You really get to see what equals what, and just, it makes a lot more sense in your mind. Okay, so if these lines are parallel, that means these are interior angles, and vice versa. So that means these are similar triangles by AA, angle, angle. So since they're similar, we can set up the proportion, the forbidden proportion. Okay, so since they're similar triangles, that means they have corresponding sides. And this problem, it's kind of easier to see them. You might want to draw them out, but I will not draw them out because me personally, I think it's pretty easy to see them since there's not many sides given. So this side, 5, is proportional to side HG. So first I'm going to take this little triangle side. It's 5 over 1.4x plus 3. That equals 12 over 6.1x minus 6.5. These are equal proportions. Even though they are different numbers, they boil down to the same thing. So we're just going to cross multiply. You might want to get your calculator out for this because it is not that easy of calculations. So we want to subtract and add to balance the equation. This means x would equal 5. Now, you might be inclined to choose 5 as your answer. Please, I beg of you, read the question. What is the length of HI? So that means it's not 2. HI is this little line here, so you have to plug 5 into this equation. And once you do that, you will get choice 4. The square pyramid below models a toy block made of maple wood. Each side of the base measures 4.5 centimeters, and the height of the pyramid is 10 centimeters. If the density of maple is 0.676 grams per centimeters cubed, what is the mass of the block to the nearest tenth of a gram? Square pyramid. This means each side of the base is equal. So all of this is 4.5. And the height is 10 centimeters. So it's asking for the mass, but it gives you the density. So this means this is a density problem. This is all given to you in the reference table, but the way I like to memorize the density equation is the DMV, Department of Motor Vehicles, the place we all know and love. And the volume of a pyramid is 1/3 base height. This is given to you in the reference table. No need to memorize it. So the volume would be 1/3 times the base. Now the base is the area. Okay, so 4.5 times 4.5. That would be 20.25 times the height, 10. This means the volume equals 67.5. So we already know the density. So the mass is unknown, and then 67.5. I like to cross multiply these, so this would mean M equals 45.63, and we see choice number 1. Question 13. In the diagram below of right triangle EFG, altitude FH intersects hypotenuse EG at H. FH equals 9, while EF equals 15. What is EG? Now, looking at this problem, you have to know what an altitude is. Now, an altitude is a line that meets another line at a right angle. So you have to know these are right angles, and if you read the problem, you would know that this is also a right angle. So we're kind of dealing with similar triangles that are right angles. So given the information below, the first thing I want to do is figure out what EH's value is. And you can easily know this. It is 12. This is a Pythagorean triple, 3, 4, 5. So you can also figure out 12 through the Pythagorean theorem. It's just way easier to know your triples, especially the simple ones. So I like to draw these kind of questions out. I'm going to draw the big triangle right here, as well as this little triangle right here. All right, so I drew out these triangles. Not the best, kind of messy, but you can just see that these are corresponding sides. So EF is corresponding to EH, as well as EG corresponding to EF. So what we're going to do with these is write a proportion. Scary, I know. We're going to take 12 and 15, put it over a fraction, and we're also going to take 15 and x, put it in a fraction. And what you do with these are just cross multiply. That gives us 18.75. Question 14. In triangle ABC below, D is a point on AB and E is a point on AC, such that DE is parallel to BC. Okay, so it is basically saying these points are on lines and they connect such that these are parallel. Which statement is always true? ADE and ABC are right angles. Well, they sure do look like it, but nothing in our givens can help us prove that. ADE and ABC as triangles are similar. So if these are parallel, that means we can use our corresponding angles and figure out these triangles are similar by angle. So yes, that is correct. Number 3 is kind of tricky. This is kind of getting at the mid-segment theorem. However, to know the mid-segment theorem, you would have to know that D is the midpoint of AB, and it's just not told on us. And the last question of this video, question number 15. If one exterior angle of a triangle is acute, then the triangle must be... All right. I like to draw these as well. So this is how I draw these type of problems. Not very to scale, but if this angle is acute, less than 90 degrees, that must mean, if these are sup angles, if 1 and 2 are supplementary, they have to equal 180. So that means 2 must equal over 90. And an angle over 90 degrees is obtuse. So this triangle is an obtuse triangle. That is the June 2022 Regents Geometry answers for questions 1 through 15.